Welcome to NTU School of Chemical and Biomedical Engineering. My name is Boon Chun, a final year student studying Chemical Engineering, currently working on my final year design project. Today, I will be giving you a tour of our Year 3 Chemical Lab as we take a sneak peek into what chemical engineering is all about so that you can make a more informed decision should you decide to pursue chemical engineering as a degree. Let's go! As the name suggests, chemical engineers deal with chemical reactions on a daily basis. No, not the kind that you have been studying in secondary schools or in junior colleges. Those are on a molecular level that are more relevant for chemists. Chemical reactions are important to chemical engineers as we aim to scale these reactions up to an industrial level and maybe up to even tons of chemicals a day. To help maintain this large amount of chemicals, there are two common types of continuous reactors that chemical engineers can employ, namely the continuously stirred tank reactors, or CSTR for short, and the plug flow tubular reactor, or PFTRs. Over here, we have a continuously stirred tank reactor, or CSTR. You can think of it as a tank with a stirrer to help ensure an even mixing of the chemicals inside the reactor. On the other hand, the plug flow tubular reactor is a tubular reactor where the chemicals enter from one end and come out of the other. Chemical engineers can choose which type of reactor that they would like to employ in their chemical plants, or even a combination of both reactors, depending on which parameters like yield or selectivity they would want to optimize. For now, let's move on to our next equipment. What we have here is a cooling tower. In fact, many chemical plants tend to operate at high temperatures to increase their rate of reactions. As a result, their products usually need to be cooled down to a lower temperature by exchanging heat with a refrigerant through a heat exchanger. The most common refrigerant we use is cooling water, which is basically just a fancy name for common tap water. When the refrigerant absorbs heat from the hot chemical products, it needs to be cooled back down to a lower temperature to be used for other purposes. The hot water enters the cooling tower from the top and flows down through the cooling tower. As it flows down, it is being exposed to air, which causes some of the water to evaporate. The remaining water is collected at the bottom and recycled back for other purposes. This concept of evaporative cooling is precisely the reason why you will feel cold after stepping out of a swimming pool. Now, let's move on to our final equipment. What we have here is a fluidized bed reactor. Fluidization is an important concept, not only in chemical processes but in the pharmaceutical industries as well. Fluidization is a phenomenon by which a fluid, either a liquid or a gas, is being passed through a bed of solid particles, causing the solid particles to behave like, well, a fluid. Let's take a closer look. Over here we have a bed of solid particles. As a small amount of air is introduced, bubbles start to form, but this is insufficient to induce fluidization. As the flow of air is slowly increased, you can see that the particles start to behave more and more like a fluid. Fluidization is important in certain processes, such as the transportation of pharmaceutical powders to be made into oral tablets. These powders consist not only of the active ingredient, but of other fillers such as coloring agents as well. By fluidizing these powders instead of pouring them, we are able to achieve a homogeneous flow, resulting in an accurate amount of drug in each tablet. It would certainly be disastrous if poor flow properties result in an inaccurate amount of drug in each tablet. We have come to the end of our lab tour for today. Thank you for joining me, and I hope that you will join us in the near future to kickstart your journey as an engineer.